Here are some reminders to help you get the most out of your DIVES CD lessons. First, work the problems with me. Work every single problem that I work and take notes on everything that I write on the board. One thing I encourage you to do is on the first practice problem, work that one with me, but then for the second and subsequent ones, pause the CD, try to work the problem on your own, then fast forward to the answer. If you got it right, great, you can move on to the next one. If you got it wrong, rewind the CD, look at how to solve the problem, and figure out how to do it correctly. Next, anytime you need to, pause and rewind the CD until you understand that particular concept. The ability to pause and rewind so easily is what makes DIVES CD lessons so much better than a live classroom lecture, so make sure and take advantage of that technology. Next, remember the purpose of math is to teach you to think and to solve problems, to effectively and efficiently think and solve problems. In the lower math levels, there's lots of mental math. In the upper levels especially, this is the most important purpose of math, is to teach you to think and to solve problems. Next, do all of the problems in the problem sets. It depends on the course that you're doing, but typically you'll do 3 to 5 problem sets a week, so that means 3 to 5 CD lessons plus a test. Next, work the homework problems and your test problems too. Work those vertically. Split your paper in two and work them vertically. And of course, make sure you show your work on your problems too. As you work them vertically, write each step down and write each subsequent step underneath the previous one. And this will help you sometimes to recognize patterns a little bit easier and help you solve the problem better. Also, use a calculator sparingly, only for geometry problems and some word problems. Don't use it for Math 7-6 or below that for any of that. Algebra half and up, use it sparingly. And lastly, have a good attitude. Every day you do school, you have a choice to make. It is your personal choice to have a good attitude, work hard, do your best, or to be lazy, complain, whine, and have a bad attitude. So choose right now to have a good attitude. Dive in, take advantage of this CD lesson, and do your best to learn the math that you're going to learn today. In Lesson 5, we'll be working with sets, absolute value, and then addition of signed numbers. Let's just start with Section A on sets. A set of numbers, that just designates a collection of numbers, basically, a specific collection of numbers. And for example, in Lesson 4, we talked about the counting numbers, and we could call that set A. And we could use brackets. A lot of times little brackets are used to enclose that set of numbers. And we know that counting numbers, those start with 1. Then you go on 2, 3, 4, and so on. So that would be a set of counting numbers. So we could say that set A equals the counting numbers, or we could have just said the counting numbers equals and then written the set. Another set of numbers that's real specific is the whole numbers, and we'll just call that set B. And those are different from counting numbers because they start with 0, and then everything else is the same. They're basically the counting numbers with 0 added. You could just think of them like that. Another important set for you to know about are the integers, and we'll call that set C. And we put our brackets or braces there. And the difference between these and whole numbers is that these include like all the counterparts or opposites of the positive number. So let's just put dots on the end to say that we start out, going negative to infinity, and then I'll just start by having -3, -2, -1. It includes 0, just like the whole numbers do, and then we start our positive numbers, and then we put dots to represent that those continue on forever. So that would be the set of numbers called integers. So sets can be specific groups of numbers with specific definitions, like set A, B, and C here. Or they could be like set D, which is just the numbers 4, 5, and 6. Now in the problem sets, you may be asked to designate the set of counting numbers, and you would do it just like we have there in set A. You could say A is the set of counting numbers which equals, and then have your braces 1, 2, 3, 4, ... Or you could just say counting numbers equals, put your braces in, a few numbers in there. Make sure you put the dots at the end though, because that represents that they continue on, and that is how the counting numbers are defined. That's how the whole numbers are defined too, that they start with 0 and then they go on forever. Now, part B is on absolute value, and let's just take a couple of numbers. Let's take -5 and +5. Now if you just looked at the numerical part of each of those numbers, the numeral, that's what absolute value is. It doesn't have anything to do with the sign. And whenever we want to find the absolute value of a number or an operation or anything like that, we put basically parallel lines around that. Say we want to know the absolute value of -8. And we represent that by those lines. So what we would say there is the absolute value of -8. That's how we would say that statement. And it would just be an 8, just the numeral part. And now we know, like when we're writing numbers, we don't put the positive sign in front of them usually. So really we're saying that it's a +8. What I would try to think about though when you're dealing with absolute value is whatever's inside those two vertical lines, just look at the number part. Or if there's an operation, say you're doing 5 minus 2, you would just say the absolute value of that was 3. Part C is on signed numbers and addition of signed numbers in particular. What they mean by signed numbers are like the integers, where they have a negative sign or a positive sign in front of them. That's what they're talking about here. And in algebra, usually you don't do subtraction. You do addition, and a problem like this, 4 minus 1, to do that in what's called algebraic addition, you would say 4 plus a -1. And I mean, you know that 4 minus 1 is 3, so hopefully you can figure out that 4 plus a -1 is also 3. A good way to understand it though is to use a number line. And so let's just make a number line. We'll start at 0 and put some tick marks on there. And let's designate 4 on that number line. So what we would do is we would start at 0 and go to the right 1, 2, 3, 4. Okay. Now we want to add -1 to that. And so what we'd have to do, and I'll just draw an arrow going the other way because that would be in the negative direction. That's moving over -1. So that means we end up at 3, just like we thought. 4 minus 1 is 3, so is 4 plus a -1. So in algebra, we do what's called adding algebraically. Instead of doing subtraction, we add a negative number. Really, all you have to do, you just kind of have to change your way of thinking about subtraction. 4 minus 1 is the same thing as 4 plus a -1. You just kind of have to change how you think about doing addition and subtraction. Using these number lines is a really good way to help you think about adding algebraically. So let's do a few more practice problems. Look at practice problem A. Let's add those two numbers together. +3 plus a +3. So first let's make a number line. And let's just put some numerals on there. 0, 1, 2, 3, 4, 5, 6, and 7. Okay. Now, I mean, I'm sure you know that that answer is 6, but you're trying to understand how to add signed numbers. So just go ahead and draw it out. You start with +3, so you always start at 0, and then you'll kind of make a little arrow to the right 3 to represent that you've added 3, and then plus another 3, so you go to the right again, 1, 2, 3, and you would end up at 6. And so that's your answer. And since they're wanting you to work with signed numbers here, just go ahead and write your answer, +6. Look at another one here, +3 plus a -2 plus a +5. So we've got 3 numbers to add here. Just go ahead and make a number line. And since I see some negative numbers in there, I'll go ahead and put a few on the number line, -2, -1, 0, 1, 2, 3, 4, 5. Now hopefully you're realizing that it doesn't matter what numbers you put on the number line, and you just have to have the right ones so that you basically don't run out of digits when you're trying to do your problems. So here we have +3 first, so let's go ahead and add a +3. We always start at 0, 1, 2, 3, and then we're going to add a -2, so let's go up so we can make our arrow to the left, -1, -2, and then we're going to add 5 to that. So let's go up, 1, 2, 3, 4, and I didn't make enough tick marks on this one, so let's add one more, because we need to go 5 spaces. And so we would stop at 6. So a +6 would be our answer here. So if you need to use a number line to add algebraically, eventually you'll get used to doing this and you won't need to. But for right now, you start at 0 and then do your addition as you need to, but you always start at 0, go to the right or the left, depending on whether it's a positive or negative number first. Let's do another one, and this time let's not use a number line. See if you can do this one on your own without the number line. I always like to add in pairs, so first I would add -2 and a +7. And so, I'm sorry, +2 and a -7. You can visualize the number line in your head if you need to, and you'd think to the right 2 and then back to the left 7, so you'd end up at -5 if you added those two together. And then plus a +3 and a +1. Now I didn't put +1 in parentheses there, but if you want to, just to keep it consistent, you can put parentheses around it and a plus sign in front of it. And so +3 plus a +1, that would be +4. And so now I have -5 plus a +4. And again, I can put parentheses just to be consistent here. And so now think about that part. You'd go to the left 5 and then back to the right 4, so you would end up at -1. And so that would be your answer there, -1. Now let's add a little bit more to this. Let's do some absolute value problems. And remember, on these you do the operation inside first, and then you take the absolute value of that result. And so the first one there, we have -6 plus 2, which is the same thing as -6 plus a +2. So just think about that. Think about a number line. You'd go to the left 6 and then back to the right 2, so you go -5, -4. So the answer there, or the sum of those two signed numbers, would be -4. The absolute value of that would just be 4. And so that would be your answer, +4 or 4, however you want to say that. Now the next problem, you have a negative on the outside of the absolute value sign. So you don't worry about that. You always will have that negative number there, or negative sign there. And so let's just simplify. Negative, and then 6 plus a -2, that would be a 4. And so the answer then, the absolute value of 4 is 4. Keep the negative on the outside, and so you'd have -4 as an answer. Because that negative is on the outside, it doesn't have anything to do with the absolute value part. Something else to think about, what if in practice problem D you would have had a negative sign on the outside? What would your answer have been then? Well, if you said -4, that would be correct. Because you would take the absolute value of -4, which is 4, and then you would put that negative sign back on. Okay, well that's all for lesson 5.